In this video, we're going to talk about how to calculate moles from grams. So we're going to be going from mass in grams and converting that into an amount of a substance, not a mass, and that's going to be in moles. And there's two basic parts to do this conversion. So first we have to have the mass of the sample in grams. And then second, we divide that by the molar mass of the sample. So we get the mass of the sample in grams from something like a balance. So that's easy. What can be more complex is getting the molar mass, and we get the molar mass from the periodic table. So here we have an example of an element from the periodic table. So this 8 is the atomic number. The O is the atomic symbol. Of course, oxygen is the name. And then usually at the bottom we have the atomic mass. And this is what's most important here. So the atomic mass of an element is exactly the same as the molar mass in value. So the units differ, but numerically these are identical. So for oxygen, 15.9994 is the atomic mass. Sometimes it's called atomic weight or relative atomic mass. And if we're doing a conversion from grams to moles, we use the molar mass of oxygen, which is 15.9994, with the units grams per mole. Okay, and we're going to use that in our conversion. As an example for this calculation, let's look at water, H2O. So the molecular weight of water we have two H's at 1 AMU each, and one O at 16 AMU. We get those straight off the periodic table. I'm rounding. And what we get is 18 AMU is the molecular weight of water. Now let's do the molar mass, because that's what we're going to be using for our conversion. And we have two H's, and that's 1 gram per mole per H. And we have one oxygen, that's 16 grams per mole. And so for water, that has 18 grams per mole as its molar mass. And what you can see is that numerically the molecular weight and the molar mass are the same for a water molecule. And this molar mass is a fraction, and it means there are 18 grams of water molecules per 1 mole of water. In other words, 1 mole of water equals 18 grams of water. And of course the mole is 6.022 times 10 to the 23rd molecules. So 6.022 times 10 to the 23rd molecules of water is equal to 1 mole, which is equal to 18 grams of water. So it's all interconnected really closely. So let's get back to the original problem. We want to go from grams to moles. And how do we do that? Let's jump right into an example. We have a balance, and it has a gold block. AU is the symbol for gold, and the balance reads 500 grams. So 500 grams is our mass of gold. We get that from the scale. To convert into moles, we need the molar mass of gold, because that's our conversion factor. So if we look at the periodic table, at gold, we see that the atomic mass, which is numerically equivalent to the molar mass of gold, is 196.9665 grams per mole gold. So that, of course, is from our periodic table. So our mass of gold is from the scale, and our conversion factor is from the periodic table. And of course, our conversion factor is the molar mass, and let's round that to 197 grams, and it's a fraction, 197 grams over 1 mole. At the very beginning, I talked about the two steps. We have our mass in grams that we want to convert, and we divide it by the molar mass. So we have 500 grams of AU, and now we divide by the molar mass of gold. The molar mass is a fraction, so instead of dividing by a fraction, it's easier to multiply by the inverse of the fraction. So 1 mole of gold over 197 grams of gold. And what makes this simple to remember is that now we can see that grams of gold, the units cancel out. What we're left with is units of moles AU, which is what we want. We want moles of gold. Numerically, 500 divided by 197 is 2.54. So 500 grams from our balance and 197 grams per mole from our periodic table. 500 grams divided by 197 grams per mole is equal to 2.54 moles of gold. Another example, we have a cup on a balance, we zero the balance, and we add water, and it reads 32 grams. So we have 32 grams of H2O. How many moles of H2O is that? Let's get our molar mass of water. So H has a molar mass of 1 gram per mole, and oxygen is 16 grams per mole, and of course there's 2 H's in water, so H2O has a molar mass of 18 grams per mole. So 32 grams of water multiplied by our conversion factor, and we want grams H2O in the denominator because we want grams H2O to cancel out and leave us with moles H2O. And of course, 1 mole of water has 18 grams in it. Multiplying grams of water by moles of water over grams of water cancels out grams. And 32 divided by 18 is 1.78. We canceled out grams of water, so we're left with moles of water. And that's our answer, 1.78 moles of water. Here we have some orange potassium dichromate on a balance. And here the balance reads 1.23 kilograms. So 1.23 kilograms of potassium dichromate, that's K2Cr2O7. We have to multiply this by an additional conversion factor to get us into units of grams. So we'll multiply kilograms of potassium dichromate by a fraction that gets rid of kilograms and gets us grams. And 1 kilogram is equal to 1,000 grams. So we get 1,230 grams of potassium dichromate. So 1,230 grams potassium dichromate. We need to multiply that by our conversion factor, which is the molar mass. So the molar mass of this, so potassium, 39 grams per mole, straight from the periodic table. Chromium has a molar mass of 52 grams per mole. And oxygen, we saw, has 16 grams per mole. There's 2 potassiums, 2 chromiums, and 7 oxygens. So we have 78 for potassium, 104 for chromium, 112 for oxygen. Adding this all together, we have a molar mass of 194 grams per mole for potassium dichromate. Let's use that conversion factor to get rid of units of grams potassium dichromate and get units of moles potassium dichromate. 1 mole has 294 grams in it. If we do the math, 1,230 divided by 294, you get 4.18 moles of potassium dichromate. So our general steps for converting mass in grams to an amount in moles. First, we have the mass of the sample in grams. If it's in kilograms, we convert it to grams. If it's in micrograms, we convert it to grams, because our conversion factor, or our molar mass, is in grams per mole. So once we have our mass in grams, we divide by the molar mass. And the molar mass is a fraction, grams per mole. So when we have grams and we divide it by grams per mole, that is exactly the same thing as having grams and multiplying it by the inverse of the denominator. So this we invert and multiply. Instead of dividing by grams per mole over here, we multiply by moles over grams, and guess what? Grams cancels out, and we're left with moles. So that's how you calculate moles from grams.